Hello, my name is Francisco, but I go as Paco. I work at Funding Circle, where I've been for almost 3 years. One of the reasons I joined Funding Circle was for the opportunity to learn about and work with Kafka. I'm also a relatively young 36-year-old that has gone through major heart and brain surgery. I share this information because I'll use it to paint a picture about testing in production systems later on. I also want to share that I'm far from being an Emacs, org mode, literate programming, or anything expert, so be nice and please share your own tips. Here's a list of the main objectives or takeaways that I wish you all get from this presentation. Identify when literate programming is a good fit, using Kafka to create production-ready streaming apps, and leverage the best practices early on for faster turnaround of Kafka Streams applications. First, let's talk a little bit about how I got using literate programming as a tool to learn new things. I consider myself a lifelong learner. It's hard for me to stay engaged on a project if I'm not learning something new. However, one of the drawbacks of being this curious or being distracted by shiny new things is that reinforcing knowledge becomes a challenge. That's why I have a particular interest in finding better ways to document things I've learned for future me. Naturally, I've gathered a vast amount of notes, gists, and code with a ton of comments that make little sense just a few days later. If I get back to something before the knowledge gets fully reinforced, I end up having to spend a lot of extra time loading up on the necessary context. Learning on the job is great and something most employers should be okay with, especially for newer employees and apprenticeship-driven roles. But it can also be hard. For example, I came to my first Clojure job not knowing much about Clojure or functional programming, and I made the wrong choice to also try to learn Emacs. I saw my coworkers doing amazing cool Clojure stuff in Emacs, and of course I wanted to learn both. I made the incorrect assumption that the power of Clojure came along with the power of Emacs, but no amount of notes practice would make me productive in a reasonable amount of time. My lead at the time suggested I just drop Emacs and actually focus on the language and less on the tooling. In hindsight, this was obvious, but my nature is to be optimistic and curious. So be aware of your limitations and optimize your learning time. One of the cool things I learned while pairing with my enlightened coworkers is that org mode in Emacs is an insanely powerful and flexible tool. There are people that use it for planning, for notes taking, but I'm not particularly organized or interested enough to use org mode as a planning tool, but I'm definitely interested in using it as a notes and documentation tool. On the subject of documentation, I've always been fond of repositories that have a hefty amount of docs, especially if the documentation is reachable via the README file. I'm especially fan of those getting started sections. My code folder is often a graveyard of failed starts. I used to copy the getting started code and paste it on my editor and run it. Then I would pat my back and call it a day, thinking that I've learned something. As you can surmise, this is never what the authors intend. I think they just want to flex their API design abilities. The Clojure community seems to have a variety of views and approaches to documentation. There are a few projects that have incredible documentation, like for example the Reframe project, and projects that just need a couple snippets. And CLJ Doc is a great project that you can go and check documentation for a lot of projects that are compatible. Back to org mode. One day I wanted to make Emacs use syntax highlighting for a code snippet I added to an org mode document. As any self-respecting developer, I went to Google for answers, and I learned about Babel. Babel is an org mode extension to work with active code on documents. Keyword active. Not only will your code snippets look pretty, but you can actually execute them and print out the output in the document directly. This reminded me about the deep learning data science community that use Jupyter notebooks or things like Gorilla REPL in the Clojure world. But I also thought that this active code concept jives particularly well with Clojure. Anyways, shortly after I found about literate programming per its definition, literate programming is a paradigm introduced by Donald Knuth in which a computer program is given an explanation of its logic in natural language, such as English, interspersed with snippets of macros and traditional source code, from which compilable source code can be generated. The more I learned and dug around, I noticed org mode, Babel, and literate programming seemed to be underrated, underhyped, and underutilized. That got me thinking that someone could not only write notes and documentation using org mode, but actually write a complete application in an easier to follow way. Instead of talking about it, let's go over a simple example of how I would set up and run a Clojure project using literate programming in org mode. First of all, we need to start by setting up our project. The idea of literate programming is that you not only have a document that lists out the steps about everything you need to do something or to write a program, but it also is supposed to run as you would run any executable and produce a compiled output. In the case of Clojure, because it's hard to know what is a compilable thing, so in this case I'm going to interpret this as producing a project file structure, but also be able to run it, to run the code. So we can run a command to set up our document structure, our file structure. We define our deps file. You can see that the headers here say that this file is not evaluated because this is actually Eden file, even though it says Clojure. I just say Clojure here because I want to get the syntax highlighting of Clojure. So while you're working on a org mode file, it's super cool to be able to evaluate the code at the code at the same time. So there is a few different ways to get set up so that CIDR knows which REPL you are using. In this case, you need to launch a REPL that has loaded the dependencies from your deps file, and there's a few ways to do it, but I describe this in this document and basically set the eval to query, because when I compile this file at the end, I want to skip the steps because the connecting to a REPL part is technically not part of the process of creating a library or a project. So once we are connected, we do get the benefit of being able to evaluate our code inline. And I can run this test as I would in the command line, but in real life, we don't really need to do that. We just want to run our test directly from our evaluated code. And in this case, the output is not super useful if you actually get the output from the run test function, but you can change this results value to something to output so that Emacs gets the value from standard out. Also, there is an interesting thing with this running snippet is that I tangle it to a Scratch file. And tangling is basically telling Emacs or org mode, this is the file that we're going to save the output to when we export our org file. And in the case of a Scratch file, I like to export all of my sort of one-off commands to that file so that I get a separate file that will, have all of this one-off commands listed out separately, aside from the code for easier reference. Finally, we actually write some library code. We'll just write a hello function that prints out hello world. We can make sure we evaluate it and we see that the results of the hello world output to standard out. There's also some really cool things that you can do with the results part. You can, if you change results to list, you can print cool lists, and if you pass it anything that looks like a list, by the way. Also, you can print out tables if you pass it an array of arrays. For maps, it's not as easy, but you can use grid print for those scenarios. Anyways, that's all that I wanted to share, but the ultimate goal here is to have a runnable project. I declare my main, and now I can tangle my buffer, which will basically save all of the files that I created. I can execute the buffer, ignore the two snippets that I wanted to ignore, and that's it. The buffer is getting executed, and we can see our final results printed out here, and there we go, a full Clojure app in a single file. Here are some references about org mode. Also, the slides in all of this presentation have links to all of the sources in the images, so be sure to download the presentation and click on the links. Now for the Kafka part of this presentation. Let's start with Kafka. So in Funding Circle, most of the software is backed or being backed or in the process of being backed by Kafka. One of the great outcomes of this is that we have no mutable locking state. In other words, our main state store is Kafka. This lets us shape data in a variety of ways that are better suited for each business domain. In our case, things like processing a loan, servicing a loan, disbursing money, handling the books, reconciling transactions, etc. There's no single model like in traditional relational databases. Instead, we only have services that produce events onto topics and services that consume from these topics, each with their own offsets. That decoupling is essential to us because data being transacted upstream does not lock any downstream process. For example, one of the monolithic systems we replaced with this architecture was in charge of originating and partitioning loans. The amount of time and I/O spent on this was unsustainable, as batch processing and reconciling daily operations was getting close to taking more than a day. As you can imagine, this is far from ideal, as we're in the business of trying to beat slow and efficient banks. Furthermore, using relational data models constrained us from being able to iterate on different approaches of servicing these loans or increasing the number of loan parts we could process. All of this is great, but we're writing applications, so we still have to deal with state. So that's where Kafka Streams comes in. Having a ton of topics and a way to consume and produce things is great, but we still need to do useful stuff. There are a ton of tools in the Kafka ecosystem. Kafka Streams is a tool under the umbrella of the main Kafka project and has a particular feature that makes it especially compatible with the Clojure ecosystem. Kafka Streams is just packaged as a library, just as Clojure is. So building Clojure apps with it becomes seamless. Jackdaw is a thin wrapper around Kafka and Kafka Stream client libraries that help us build streaming apps. Jackdaw also contains functions that serialize and deserialize records as JSON, Eden, Avro, etc., as well as functions for writing unit tests and integration tests. Now let's talk about how we actually deploy this Kafka Streams applications in production. During my time at Funding Circle, I worked in a few different teams. Teams at Funding Circle operate on common infrastructure and share as much as it's feasible, but when it comes to practices around putting an app in production, I've noticed that it's kind of like the Wild West. So I've taken it upon myself to gather some of the best practices I've seen applied in FC and share them here. I know none of the following practices or patterns are novel, but from the sea of best practices and software patterns out there, these have been the ones that have the most beneficial impact on Kafka Streams applications. When it comes to best practices around deploying applications to production, I think that the most important thing practices are around testing. So I'm going to talk about testing a lot. The test pyramid or the testing pyramid is a common and popular way to think about how much and what to test. This can be interpreted in a variety of ways depending on what you define as the target system. I've had endless debates on what is considered the boundaries between an integration and a unit test in Clojure applications. Also, in a microservices architecture, finding the scope of what should be tested versus what should be mocked becomes really hard. In the particular case of Kafka Streams apps, it also gets complicated because the Kafka Streams Java API is really a DSL that represents applications as topologies. The actual low-level calls that allow you to see the applications as just a series of transformations on nodes are abstractions. So if you're testing behavior using this DSL, are you technically doing an integration test? Maybe. I could go on forever about this, but for practical purposes, we generally consider any test we run without needing to run Kafka as a unit test. It is very easy to abstract business logic into function thanks to Jackdaw. We can also assume that the Kafka Streams Transformations DSL is always correct. The problem comes when you want to validate behavior of a topology as data is flowing through it. In an ideal world, all of your tests should be free of external dependencies. Unfortunately, that's not the case for Kafka Streams apps because there's a lot more to validating a topology. Mainly, you want to validate the data coming in and out of topology nodes is in the right shape using the correct schema. At Funding Circle, we use Avro to define schemas for most of our topics. It is super common to run into bugs where data in the topology looks good, but it doesn't match the schema or the other way around. Fortunately, we have ways to deal with this using unit tests. Is a Clojure presentation after all. So yeah, the answer is always specs, duh. For dealing with schemas versus data in our topologies, we rely on Clojure specs. Having specs to describe data is great, but we also use it to generate Avro schemas we're going to publish. We created a spec to Avro compiler, which we use to publish and update Avro schemas that our topics support. Our tests can rely on spec generators to produce any dummy data we want to test with, and we can gain the ultimate confidence of our tests also by using generative testing. Recently, we've been able to create different sets of specs for reading and writing operations as the schema constraints of writing to a topic and reading from a topic drift over time as the schema evolves. This is particularly more painful because of our use of Avro. The pain comes when we need to evolve schemas. Avro is very strict about backwards compatibility, so we always need to keep that in mind. For validating the behavior of a topology, we now rely on Test Machine. This is a newer addition to the Jackdaw library that uses the topology test driver that appeared on Kafka 2.4. It allows us to create a fixture that lets us call a topology without the need to run Kafka. This is actually a very interesting subject, but it's a little bit out of scope of this presentation. I'll add a link to the references where you can learn more about this subject. The topology test driver allows us to cover most of our integration test needs without the need to run Kafka, but sometimes we want to test behavior of more than one topology at a time. The test driver only supports running one topology at a time. For scenarios like this and others, Test Machine actually supports multiple drivers. This lets us set up tests that can run against Kafka or Kafka REST proxy. This is a super powerful feature in Jackdaw that I'll showcase in a bit. So now we're at the top of the pyramid, and here is where we have our expensive tests. The ones that test the whole system, the ones that when they fail, they leave you wondering what happened. This always connects me to my personal health story. On my first year of college, I fell into a medical hardship due to a very expensive and inconclusive test. I was misdiagnosed with epilepsy after a few consecutive fainting spells. I was young and inexperienced and let fear put me in a treatment I couldn't afford and did not need. Years later, and with a lot of research on my own, I decided there was no reason for me to continue this treatment. I had no answers for the fainting spells, but I sure did not have epilepsy. This was an emotionally taxing time, and it eventually led me to start taking SSRIs. A psychiatrist diagnosed my anxiety with simple observations, simple tests, if you will. Years later, the fainting spells came back. I still had no diagnosis. I had moved to San Francisco, and the doctors of this side of the border still had no clue. One night, the right circumstances for the diagnosis came after I passed out following a somewhat strong earthquake. My girlfriend, wife, saw me pass out and insisted we go to the hospital in spite of me telling her that this is just something that happened to me. Luckily for me, I passed out again at the hospital while I was connected to beeping machines. They saw my heart flatline. Much like bugs in production, this problem was not reproducible under normal circumstances. Turns out I have a rare condition linked to dehydration and other environmental factors that causes my vasovagal response to be quite severe. Each one of those times I was passing out, I was not fainting, I was actually rebooting, dying and coming back to life. I left the hospital a few weeks later with a pacemaker. Fainting, mystery solved. And what about that brain surgery, you might ask? Well, remember those expensive tests a long time ago? Much like with code, expensive tests can yield misleading results. Only back then, the doctors were not looking at the right thing. They missed that I had a super rare and deadly benign tumor that was starting to form in my brain. They just focused on ruling out the bigger, non-deadly benign tumor that was also in another region in my brain. 10 years after that first expensive test, I decided to follow up on that benign tumor that was deemed unrelated to my fainting spells. I wanted to see if it had anything to do with some minor headaches I was having at the time. Turns out the other deadly tumor was close to becoming a real big problem. Shortly after, I had brain surgery to remove it. I was spared from a really terrible outcome by chance and by a radiologist that wasn't distracted by my fainting spells. Moral of the story is that the top of the testing pyramid is not bad, but its value is only worth if you know what you're looking for. Wouldn't it be nice if our bodies spit out logs about everything that happened inside of them? No, not really. I know logging can be annoying, verbose, and useless. In recent years, the practice of structured logging has become more popular to mitigate this problem. This practice also jives well with the "it's just data" Clojure mantra. The idea is fairly straightforward. We log data instead of unstructured text. This has many benefits, like making it easier to find needles in stacks upon stacks of logs produced by multiple services, but also makes problems easier to diagnose and trace. This practice is not without its flaws, but it can be greatly mitigated by using it effectively. Some of the best practices I want to share are: create common logging APIs shared across your namespaces. This has the benefit of being able to be shared across projects, and you can also enforce the usage of common field names. Don't get too crazy with logging too much data, because you can overload the logging system, as we have learned. Also, create runbooks and alerts that include the logging queries. This way, when you get an alert on your phone or in your email, you can just click on a link, go to the logging query that will yield the data that you need, and you're right there debugging your system. Structured logging alone is not enough for diagnosis of production systems. Real-time information is as important as valuable. Much like that heart monitor that showed me flatline led to my heart diagnosis, no volume of data will have as much impact as real-time feedback. Metrics can also be misutilized. So here are some of the main practices I recommend for metrics. Definitely gather detailed JVM memory metrics because we're using the JVM and it's volatile. Instrument your logging events to produce metrics. This allows you to cross-reference your logging data with real-time events happening in your system. This makes you gain confidence, and you can create custom alerts and events for that buggy behavior. Publish Kafka Streams custom metrics. All of the Kafka Streams apps produce the same type of metrics, so you can produce common dashboards across different apps. Also, being able to see the consumer offsets is the single most important and priceless metric for any Kafka Streams application. For the production app demo, I'm going to fly by most of it, and you can assume that a lot of this is very similar to the simple demo that we just saw. I'm just going to focus on the stuff that I talked about and let you come back to this documents on your own time. So first we set up the project, same as with the basic project. We just have a larger structure that requires more of those supporting things we talked about in the slides. We have a larger depths file that has a lot of all of the dependencies needed for the structure around a production application. Generally, the structure of our app is formed by the use of integrant and op-based config. We'll see how that gets all glued up together. For logging, we're going to use the Cambium libraries. I think they have the best in-class support for structured logging. They also use the logback backend, and the logback is fairly easy to deal with and to configure. For metrics and reporting, we're going to use the Clojure metrics library alongside Prometheus. There's other supporting stuff we use, like depthstar for building our jar file, and Clojure test runner, and other things that you can review on your own later. I'm not going to show all the topology. I'm just going to describe it using GraphViz. This is a great way to understand problems, and you can render this graphics in line. For example, in this case, we can evaluate our dot file, and we can actually also print it in line. In this case, it kind of looks weird with my weird background. So I'm going to go ahead and change the background in line so that it looks good in Emacs, although you might want it to publish it as transparent. So we say white background, and reevaluate it. Cool. So our topology has two sides. One side of the topology on here, it receives the external loan application data from a topic and then updates the internal state store with the state of the loan. And then it updates the SBA loan application updated topic with the current state of the topic, eventually just marking the topic as complete at some point. When that topic is complete, an external user from an upstream system will be able to trigger a loan submit after they've validated that the loan is ready to send. So once they trigger that loan, we get that message, and then we call SBA directly and fetch the results. As far as supporting code goes, here are the three main things that we're going to rely on. First is a data model, which we rely on specs, as I mentioned before. I'm not going to show all the specs, but basically the gist is that we have our reader and writer specs, as I described earlier. Then we have our logging and metrics stuff. For logging, as I mentioned, we have our custom logging namespace that has your typical logging functions that can be, personalized or changed later if your logging backend changes. But we also have this logger function that generalizes a bunch of things so that we can also gather a bunch of information, but also produce metrics at the same time. Alongside with the logging namespace, you need your logging configuration. We have our logback test configuration that saves the output to a file in JSON pre-printed format for local development purposes. And then for production, we just print a standard out, and our log manager will just pick up those logs in JSON, then take them to Graylog and process them. We are able to bake in the transducer's functionality into the Kafka Stream DSL with some intelligent code. This code is not part of Jackdaw yet, but I'll put it here, a version of it that might or might not end up in Jackdaw in the future. But the most important thing is that you see we have a transduce function that applies our transformations to a Kafka stream, which is really, really neat. I won't go into detail with the topology, but the gist is that there is our topology that has two sides. You can roughly see it here. There's the side that takes in a new external application, transduces, and updates the application. In the transducer, the application state gets updated, and then on the other side, we publish to the SBA loan application updated. The other side of the topology takes in an external trigger and looks into the internal state store for that corresponding opportunity and uses it to call the SBA and fetch a result. It then pushes that result to the SBA results available topic. The part of the demo that I want to focus on is actually testing. This is a very simple unit test that validates one of the sides of the topology, the one that updates the application loan state. As you can see, we have very simple setup. We use a generator to create our input to our test, which we apply to a transduce function directly. We don't need Kafka for any of this, and yet we're still validating the flow, the full transformation of a topology. On the other side, we validate that the opportunity ID gets added to the state of the system. We validate that the loan application is set to complete if we so want, but also we can validate things like our metrics are being produced. We also want to test what happens if we generate an invalid loan application and put it through the topology. In this case, we generate a valid loan application with our generator, remove an attribute like zip code, pass it through the transducer, and validate that the loan application is set to complete and that it includes the problems. This is great for debugging, for example. We can also see the logging output. For example, in this case, I can even export it with a JSON wrapper so that in org mode, it looks out pretty nice. Finally, we get to the integration test, which is the most important part of all of this because you can actually get to see how the system would actually behave in a running instance in production without actually needing to. All this thanks to test machine. There's a bunch of scaffolding that is required to set up test machine in a way that it can be used as fixtures inside of a Clojure test, which is not part of Jackdaw yet. It will probably be part of Jackdaw soon. So I include these namespaces directly. Our integration test fits in just a few lines where we can see all of the commands that we pass through our topology. And on the other side, we just validate that the outcome of everything that happened inside of that machine or that black box is correct. In this case, we produce our external loan application. We wait for the loan application updated to be produced. We then write our trigger that will make us call SBA and then wait for the SBA result available event. We previously had set up mock call to the SBA, of course, because this is a test that we want to run in our test suite without any external dependencies. But we can see that when we run them, we at the end will get a valid results available event, a loan number, which is a loan number that will come from our mocked government box, which is the SBA in this case, and that our opportunity ID matches the opportunity ID that we generated. We ran a whole working topology without the need of Kafka, which is pretty impressive. As promised, here are more references that you can go look into if you want to know more about Kafka streams and Jackdaw. There's more references hidden in the slides, so be sure to download the slides and check them out. Thanks for listening. I hope this was useful for you, and hopefully you'll do some practicing with literate programming and use Kafka in production systems. So goodbye. Thank you.